9.3. So let's first have a look at the theorem 9.2. Two triangles on the same base and between the same parallels are equal in area. Okay, so which two triangles will be considering? Triangle ABC and then triangle PBC. Okay, these are two triangles. When you look at them, can you see that they have the same base BC, same base, and also they are on the same parallel, right? Which means the area should be equal. Okay, area of this triangle ABC should be equal to the area of this triangle PBC. Clear? All right. Now the next is the converse. Okay, two triangles on the same base and equal, and if they have equal area. Okay, so same base, and let's say the area of this triangle ABC equals area of this triangle PBC. So if they're on the same base and they have equal area, we can just simply conclude that even their height will be same, or they'll be between the same parallels. All right. Okay, if we're done with it, let's solve this question. Given figure, E is any point on the median AD of triangle ABC. Show that area of triangle ABE equals ACE. So question is given to us that this is the median. Okay, and what does the median do? It will divide a triangle into two equal parts or two equal areas. Okay, so this is the AD is the median of triangle ABC. That is what the question is saying, right? Which means that area of this triangle ABD should be equal to area of this triangle ADC. All right, keep that in your mind. Okay, so what are we also prove? We also prove that area of triangle this ABE should be equal to area of this triangle ACE. Okay, that is what we are asked to prove. Alright, so let's start. So write down the given, and also because remember this is the median, right? So remember this will be the midpoint. That means BD equals CD, right? Okay, proof. Now since AD is a median, like I told you, this is a median, right? Which means of triangle ABC. Therefore, this area should be equal to this area, like I've already said. So I'm just going a little fast here. So I've written here, the areas are equal. And why? Because median divides a triangle into equal areas. Okay. Now see, can I again say the ED is a median of triangle ABC? All right. Now have a look here. Let's say that we have a triangle here. This is side BC, right, and this is the median. Okay, this is the midpoint D, right? So see, no matter where I draw, right, these two areas will always be equal, or this will become the median. Okay, in case even if I go higher, you will notice that, let's say that like this. Again, we have a pointer. See, can you see it will always divide into two equal triangles, right? Which means that this will always become the median. Okay, so same thing here. For this reason, when you look at the smaller triangle, right, give me a sec. When you look at the smaller triangle, this, okay, they have said this is the midpoint, right? So like I showed you from the example when we were doing here, this will become the median again. All right, ED will become the median of this triangle EBC, right? Which means this area should be equal to this area. All right, so that is what I'm going to simply, I'm writing it down here. ED is a median, therefore area of this triangle EBD or EDB should be equal to area of triangle EDC. Okay, now if we're done with that, we'll subtract 2 from 1. All right, so when you look at 1, write on left hand side minus left hand side, right? Left hand side minus left hand side I've written, and again right hand side minus right hand side. All right, now area of ADB, when you look at ADB, this is the area, right? The whole area minus area of triangle EDB, which means the smaller triangle. So when I subtract the bigger from the smaller, do I get this area? This area will be left, right? So area ABE. Okay, same thing for right hand side. The bigger triangle this minus the smaller triangle this, I'll be left with this area, or ACE, which is our proof. All right. Okay, let's go to the next question. 2 in a triangle ABC. Now therefore given us E is the midpoint of the median AD. Okay, remember once again, this is a median, which means this big triangle, this triangle should be equal to this triangle again. All right. So we also prove that BED, this, right, is 1/4 times the area of triangle ABC, the whole triangle ABC. Okay, that is what we also prove. So once again, can I say that ABD equals ADC? We can say, right, because remember in this entire big triangle, the question already gave us that AD is a median, which means this is equal to this, right? ABD equals area of triangle ADC, right? Now because of that, can I write that area of triangle ABD equals half times the area of triangle ABC? It is half, right? Half times the whole triangle. Okay, so there is what I'm writing down. ABD equals half times the whole triangle ABC. Okay, now let us look at the smaller triangle again. Now this ABD. All right, the question already gave us what? This is the midpoint, right? This is the midpoint of the median AD, which means once again this will also become the median. Okay, that means BE is a median, which means this triangle, the area of this triangle, this should be called the area of this triangle again. Clear? So that is what I'm going to write it down. You can already see here, right? Area of triangle BED, right? BED equals area of triangle BAE, right? Now this area of this triangle BED, can I write it half times the whole triangle? I can write it down, right? Half times the whole triangle ABD. But now when you look at ABD from equation 1, ABD is what? Half times the area of triangle ABC, right? So I'm substituting in place of area of triangle ABD, I'm writing the half times the area of triangle ABC, substituting. Okay, then when you multiply 2 to the, you get 4, right? Or we're going to get area of triangle BED equals 1/4 times the area of triangle ABC. Okay, which is our proof.